Alright, this is part 2 of the T1 training session video. Alright, so I'm going to clean this text out. And so there's a camera built in. And if you have problems establishing your connectivity, there's a video called Establishing Connectivity where it talks about going through, refreshing your COM ports. So let me just do that quick. If I unplug my printer and then reconnect it, we'll probably get assigned a new COM port. So if I try to move it now, nothing. If I look here, that's old text, but if I look on the COM link here, there's nothing. If I do refresh on my COM port, now I see that the printer, since I disconnected it and reconnected it, now it's been assigned to COM port number 8. This is always the baud rate, apply, ping. And we're still sending our transmit stuff, so I'm going to not echo that, and it just gave some data here for T91, which is our hotbed controller. So now I can just move it, park. It's making that noise because I don't have all the screws tightened, because I'm always putting heads in and out of it. And also there are certain combinations of XY velocity that are going to set up a resonance frequency. It'll just amplify the sound. On the camera, there is a camera built in. So if I come here, I'm going to refresh my camera list, and I'm going to select the PC camera, and I'm going to turn it on. This is a camera that's on the yoke that points down on the bed. So if I place something, if I place this thing on the bed, I can move the camera over. And what this is intended for is for using those crosshairs. If we're going to have multiple heads cooperate on the same print, you would print a test pattern of a big plus sign, basically, with the heads that are going to cooperate. And you come over here and put these crosshairs on the center of one print, then you set these numbers to 0, and you go over approximately 35 millimeters. And you should be close to where the next head is, because the slots are 35 millimeters apart, and you might go to fine move and adjust that over, and you would snatch those settings onto a print head, but I don't have one loaded now, and then flash them to the head so that when you did a tool change executing your G code, the printer would know how far to move to compensate for the difference in the distance where the placement of those nozzles are. We don't need to get into that now. There's also an M790. If I have this checked, then every time my G code executes an M790 command, it will take an image. However, since the yoke is moving, this isn't the best camera to take a time lapse like this. It's better if you add another USB camera to the printer, plug it in on the printer, specify it up here, and then every time there's a layer change, which we can see here if I search for M790, every time there's a layer change, it executes new layer actions. This is for layer 0, layer 1, layer 2, layer 3. So you would wind up basically with a time delay, a series of images stored in a folder which is named after your G-code file, and each image will be named in a layer number that it is. Okay. The rest of these tabs I don't even play with. They're for advanced functions, and you can talk to us if you have special needs. All right, that covers an overview of the software. Now let's come over here and look at the hardware. So I'm going to unlock my motors. This is our X bed. It moves up and down in the Z, and also left, right, in the X. Our yoke comes forward and rearward in the Y axis. Now, we don't know what type of surface. We provide a sheet of glass with every printer. Some people like to print inside of specimen trays or petri dishes. Some people like to print on a layer of build tack or a sheet of sandpaper or painter's tape. But whatever surface you're going to print on, or you want to print on some existing object, we want to make sure that the surface we're going to print on is level. So you'll use this tramming gauge, which is an analog gauge, or you may have a digital version. This bed has got a solid post underneath that should support the center, and each corner is spring-loaded and adjustable. So what we're going to do is we're going to set this in the center, and I'm just going to bring the bed up to ensure that I have good engagement on the probe. And I'm just going to set the 0 to the top of the dial and use small movements. And I'm going to come down here and use even smaller movements until I'm at 0. Each of these movements I just made is 20 microns, or about 4/5 of a thousandth of an inch. Now that I've got the center set to an arbitrary 0, I'm going to unlock my motors again. And I'm going to compare the corners to the center. So I'm going to come over here and look at my back left corner, and it looks like it's about 1/1000th of an inch low. So I'm going to take my Phillips screwdriver and I'm just going to loosen this screw a little bit if I can find it. So I'm at 0. We'll check the front left. Front left looks good. Front right. Front right's low, so we're going to loosen that guy a little bit more. And then the right rear. That looks good. So we're level to plus or minus 1/2 thousandth of an inch, or about 12, 13 microns. Probably a little bit better than that just here because there wasn't much variation. In general, I recommend to people that you want your bed to be level within 10% of your layer height, and that really means your first layer height. So if you're going down to 100 microns, this would be fine. If you're going to print layers of less than 100 microns, which you can do, 75 microns, 61. We've done as low as 25 microns with ABS. That's fine, but we recommend you set layer number 1 to be 100 microns, and then the rest of your layers to be a thinner layer, because your glass might not be level to within 5 microns across the entire surface. Once your bed is level, you're ready to load your heads, and if your G-code is ready, you can just start your first print, or if you want to slice and do something, then that would be the next step. For that, you want to go to the next video, which should be either for loading your head for your emulsifiable head, your EMO25, or your MK1250, or whatever head you're going to use, or see the video about slicing.